Good day. Today we are going to continue with continuous random variables, and we are going to look at the last three probability distributions. So we are going to consider the last sections of chapter 8. If you look at the outcomes in the study guide, you should be able to calculate probabilities for the t-distribution, and you should understand when to use the interpolation formula and when it is not necessary. Then we will also calculate probabilities for the chi-square distribution and for the F distribution. We applied the central limit theorem when we worked with large sample sizes, but now we are going to apply the student's t-distribution, or the t-distribution for short, when we work with small sample sizes, and that means that our sample size is less than or equal to 30. Then if you look at the formula that we use to transform the value of our sample mean into a t-random variable, it's similar to the one that we used for the central limit theorem. The only difference is that our population standard deviation is now unknown, so we can estimate that value with our sample standard deviation that you covered in chapter 5 in STTN 111. But for now, your t values will be given, and we are just going to practice using the t-table to look up the probabilities in this chapter. But later on in chapters 9 and 10, you will have to estimate that value yourself. Then your random variable t follows a t-distribution with n-1 degrees of freedom. So you take your sample size and you subtract 1 from that, and that will be a column then in your t-table that you will use to look up your probability values. The t-distribution is also symmetrical around the population mean of 0, like your standard normal distribution, but we have wider tails since we are working with smaller sample sizes, which is an indication that there is more variation in the data because the population is represented to a lesser degree. So if my sample size gets larger, then my t-distribution will tend towards the standard normal distribution. For example, if the line in blue indicates the standard normal distribution, then the line in pink indicates a sample size of 6, which means that our degrees of freedom will be 5, and the line in green indicates a sample size of 3 and our degrees of freedom will be 2. So you will see that as my sample size increase, my t-distribution will tend more towards the standard normal distribution, so the variation will become less. For the t-distribution, we want to calculate the probability that our random variable t is less than some critical t value from our t-table, where t follows a t-distribution with n-1 degrees of freedom. Now, in your t-table, the probability values are only given to the left-hand side of a positive critical value. So, if you want to determine the probability to the right-hand side, you will have to say 1 minus the probability that t is less than that critical t value. If that critical value is found directly in our table, we can just read off the probability. But if it's not found directly in our table, it means that that critical value will lie between two t values, t1 and t2 in our table, and that means consequently that our probability will always also lie between two probability values p1 and p2. So then you need to use this interpolation formula to calculate your probability. The t-table is found in Appendix C2 in your textbook, and it spans over 3 pages for different degrees of freedom, and the layout of the table is as follows. The column here on my left-hand side is my degrees of freedom, and the row at the top gives me the probability to the left-hand side of a positive t value. So that will be my probability to the left-hand side, alpha, indicated in the diagram. and then inside the table I find my critical t values. So let's say, for example, we have a degrees of freedom of 5, and we want to determine the probability that t is less than 0.559. Then I have that critical value in my table, and I can then simply read off my probability value because it is to the left hand side, and that will give us a probability value of 0.700. But if that t value was not directly found in the table, then I would have to apply my interpolation formula. So let's look at an example of that. So in example 8.31 on page 241, they tell you, calculate the following probability. The probability that t is greater than 1.875. So that's our given t value. And they tell you that t follows a student's t distribution with 24 degrees of freedom. On the first page, you go down to a degrees of freedom of 24 then. If you look in that row, you see that you won't see a value of 1.875, so we can move over to the second page. Going down to degrees of freedom of 24 again, we look in that row and you can still not see 1.875, so we move over to the third page. And then going down to degrees of freedom of 24, 1.875 is not there, but we can see that it will lie between those two values. So the value to the left of TG, which was 1.875, will be my T1 in my interpolation formula. The value on the right, to the right hand side of TG, which was 1.875, will then be my T2. And then if I go up in that column, that 0.960 will be my P1 in my interpolation formula, and the value next to that will be my P2 in my interpolation formula of 0.965. So these are the values that we identified from our t table then that we can use to plug into our interpolation formula. But we were looking for the probability that t is to the right hand side of 1.875. But remember, the values are only given to the left hand side in my t table. So I need to change that to 1 minus the probability that t is less than 1.875, since the area under my curve is 1 and I have the value to the left. So that will that difference will give me the probability value to the right. So plugging in those formula values in the formula, I can subtract that from 1. So our probability will be 0.037. And remember, you are still the intelligent one behind your calculator, so please just input these values correctly. You can try this class example then, please, where I ask you to calculate the probability that t will be greater than 2.201, and I tell you that t follows a student's t distribution with a sample size of 6. Now you need to be careful. Your sample size is 6, so that will make your degrees of freedom 5. So I will use a degrees of freedom of 5 in my t table and not 6. So in an exam or test question, just read carefully whether I give you the sample size or whether I give you the degrees of freedom directly, like in the previous example. Going down to a degrees of freedom value of 5, on the third page of the t table, you will see that 2.201 will lie between these two values. So 2.191 will be our T1 in our interpolation formula. 2.297 will then be T2. If I go up, that 0.960 will be P1 and the 0.965 will be our P2. Like in the previous example, I again asked for the probability that t will be greater than a tg value. So we are looking for the area to the right of that value in our t table. We only have the values to the left hand side. but the area under the curve is 1, so 1 minus this probability that I can find will give us the probability to the right. So we will say that probability will equal 1 minus the probability that t is less than 2.201, and then you can plug in your values into your interpolation formula, those that you looked up from the t-table, and if you round off to 3 decimal places, your probability will then be 0.040. You can then try exercise 40 on the t-distribution, please. Then for the chi-square distribution, we use the degrees of freedom of n in our chi-squared table, and then this is the notation that we use to indicate that a random variable follows a chi-square distribution with n degrees of freedom. So we use this Greek symbol chi. Then the random variable for this distribution can only take on positive values, and its density function is skewed to the right. But as our sample size and consequently our degrees of freedom increase, this density function will become more symmetric. For example, if you look at figure 8.30, you will see that I give you a density function with a degrees of freedom of 4 and a density function with a degrees of freedom of 10. Then this one is definitely less skewed than the one with a degrees of freedom of 4. So this one became more symmetric. The probabilities in your chi-square table is given to the right-hand side of a positive critical chi-squared value. So the notation that we use to indicate probabilities for the chi-square distribution is the probability that your random variable is greater than some critical chi-squared value is equal to alpha, and that will be your probability. And it's also indicated here with your critical value. And your random variable then follows a chi-square distribution with n degrees of freedom. The chi-square table is given in Appendix C3 in your textbook, and it spans over 2 pages for different degrees of freedom values. So it works similar to your t-table. You have your degrees of freedom values here on the left-hand side. Then the alpha row at the top gives your probability values to the right-hand side of a critical chi-squared value, and your critical chi-squared values is found inside the table. For example, in example 8.32, they ask you to determine the value of k such that the probability that your random variable x is greater than k is 0.1, and they tell you that your random variable has a chi-square distribution with 8 degrees of freedom. So they give you the probability value now to the right-hand side of a positive k value, and they want the critical value then. So you go down to a degrees of freedom value of 8 in your chi-squared table. Then it was given that our probability to the right-hand side of k is 0.1. So we can use that value directly. And then our critical value will be 13.4. So k is 13.4. Then in example 8.33, they ask you the same question but in a different format. So they use the notation to indicate that. So they tell you that you have a chi-square distribution with 8 degrees of freedom, and then alpha indicates your probability to the right-hand side here, which was 0.1. So our critical value will also be 13.4. In example 8.34, they ask you to determine the probability that your random variable is less than 22.4, and they tell you that your random variable follows a chi-square distribution with 13 degrees of freedom. So we will go down to degrees of freedom of 13 in our chi-square table, and we look for 22.4. And that will give us the probability to the right-hand side of 22.4 then. So that will be 0.05. but they ask for the probability that your random variable is less than 22.4, and again the area under your density curve is equal to 1. So 1 minus the probability that we looked up to the right hand side of 22.4 will be 1 minus 0.05, so our probability will be 0.95. You can try exercises 41A, B, C, and D on the chi-square distribution, please. You can leave question E because it works on linear interpolation for the chi-square distribution, but that is not covered in the module outcomes. The last distribution is the F distribution then, and the F distribution also has a positively skewed probability density function, but our F table works with 2 degrees of freedom. V1 is the column that we are going to use in our F table, and V2 gives us the row that we are going to use in our F table. Then the notation that we use to indicate probabilities is similar to the chi-square distribution, where we determine the probability that our random variable is greater than some F critical value with V1 and V2 degrees of freedom, and that probability will be equal to alpha. And our random variable follows the F distribution then with V1 and V2 degrees of freedom. Then you will see that there's 2 F tables in your textbook, a 0.01 table and a 0.05 probability table. Your F tables is found in Appendix C4A and B in your textbook, and it spans over these 4 pages. So in your F table, V1 is found here at the top row, and V2 is your column here on the left hand side. And then we find our critical F values inside the table. Then the probability for the 0.05 table will be 0.05 for all these critical F values. And then for the 0.01 table, the probabilities will be 0.01 for all those critical F values. Let's look at an example on the F distribution. In example 8.35 on page 243, they tell you determine the value of k such that the probability that your random variable is greater than k is 0.05. And then they tell you that your random variable has a F distribution with 5 and 10 degrees of freedom. So they give you the probability, and that means that we are going to use our 0.05 F table, and V1 is going to be 5, and the second degrees of freedom that they give you will be your V2. Going to column 5 then, and going down to row 10 will give us a critical value of 3.33, so K will be 3.33. In example 8.36, they also ask you to determine the critical F value, but they use this notation. So our V1 will be 7, V2 will be 8, and they tell you the probability is 0.01, so you will use your 0.01 table to determine that critical F value. So going to column 7 in your 0.01 F table and going down to row 8, your critical value will be 6.18. You can try this class exercise on the F distribution then, please. Okay, so I told you that your random variable follows the F distribution with 4 and 10 degrees of freedom, and I want you to determine the critical value such that the probability that your random variable will be less than the critical value will be 0.95. So first of all, our V1 will be equal to 4 and V2 will be equal to 10. The probability to the left-hand side of your critical value is 0.95. So that means that your probability to the right-hand side of that critical value will be 0.05. So I'm going to use the 0.05 F table, and that will make us our critical value 3.48. Thank Thank you. That's then the end of chapter 8.